So I'm Haseeb Budhani. Guess I'm going to be driving this clown train. Let me just jump in. I had a number of things I'd set up, in terms of breaking the ice, but I guess I've already done that, and he took away my intro. So I'll just jump in. So let me just start with the cast of characters the guys will be talking to you today. So I'll do most of the emceeing, and I'll spend maybe a few minutes up front, talk about, with the assumption that some may not entirely know what we do in particular as part of the WAN optimization space. I'll just talk about who do we sell to and what do they use our products for. A few minutes, not waste your time, and then we'll get into the fun stuff. So we have Dr. Ram. Ram is our CTO, he's our founder. He's the guy who came up with the cool stuff. He's going to do a lot of stuff on the whiteboard, talk about some of the historic background on deduplication and why we think it doesn't work, how he has come up with a brand new way of solving the problem. So that should be a fun conversation, and you guys can really dig in. And it should be, actually, I think, Derek, you tweeted your nerd meter was high. We're going to take it way high. It's going to be fun, right? Once he's done, we'll come back and talk about the system, what it looks like, how we're different from everybody else out there. Really, in terms of how we've architected the system, it's just pretty unique stuff compared to what everybody else does. And also talk about some of the TCP optimization work we've done, which we feel is quite unique in terms of how we manage congestion control and all that. Throughout, we'll start a demo. So in a little bit, in about 5 minutes, Umair is going to kick off a demo. And what we'll do is we'll kick it off, and we'll come back in 30 minutes and take a look, because we don't want to spend too much time on just looking at a screen. We just kind of come back and show you the results. But again, we have a script in place. If you guys want to focus on something in particular, we can do that. We got lots of stuff to talk about. We can use the whiteboard, whatever you like. So we try to keep kind of true to our plan, but please, whatever you like to do, we'll do that. So everybody, like I said before, everybody's technical. Please feel free to ask whatever questions you want. Yeah? So let me just overview. So we asked this question before, how many people know about WAN optimization? So when you think WAN optimization, what's one company that comes to mind? Don't say Cisco.
Cisco?
Riverbed, right?
Citrix.
They do it. Citrix, yeah, I was there. So I was part of that orbital team that got it.
Really?
So, sorry? But that product is dead now as far as I know.
Yeah, it is. Yeah.
So, Riverbed or Cisco for that matter. Yeah, that was never, but 2003 was a great product. So what Riverbed and Cisco have done for WAN optimization for the branch, we do for the data center. Right? The way we look at the space, WAN optimization, it's optimization, so it's a pretty large space. There are two distinct markets in here. There's the branch market, which is where Riverbed has done an excellent job. And if you have a branch problem, if you have a file sharing problem, I will tell you go buy Riverbed. It's a great product. But there's a different market, which is data center to data center, because the applications are different. We're not talking about some user double-clicking on a folder. That's not the use case we're talking about. We're talking about high-speed replication, lots of backup, lots of file transfers, very different use case. And I'll share a couple of use cases in a little bit. And the architecture, how we design this product is entirely different, because when you are designing a system for a 2 megabit WAN where serialization delays are an eternity, you can do things on an x86 and it's fine. Right, but we have to think through things in a very different fashion, and that's what Ashish is going to talk about when he talks about the architecture. So really, it's two different things, and I just want to make sure up front, you guys, when you guys kind of think of us and when you bucket us, we're not like a Riverbed. We're doing what Riverbed does for the branch for the data center. Fair? Any questions, concerns on that? So this is the product. It's sitting right here. I'll pick it up. I'll show you the board in a little bit if you guys want to see it. It's a 2-year device. It's the only 10 gigabit WAN optimization solution out there. There's a lot of demos about 10 gig, but it's 10 gig, and you guys can play with it offline if you want. We can do a lot of things with the box if you like. And we have a demo that's going to show you like 9 gig traffic running through the box. Nobody has this. There's no product out there. If you ignore there's marketing and there's reality, right? There's no product out there that gets you the speeds that we're talking about here. Our focus, like I said before, only data centers, and there's no branch. We don't focus on any branch stuff, no email acceleration, no SharePoint, none of that. Pure replication, backup, high-speed stuff. That's what we are all about. This is a marketing thing, but even in terms of how we price this product, how customers think of this in terms of ROI, this is our customers appreciate how quickly they can pay back this product, how much money they spend on it because of how we've designed it. For a single box we sell, it's a 10 gig box. Comparatively, actually, we're doing a bake-off against a large company that one of you have mentioned already. They're going to propose, what was it, Ashish? 11 boxes for the same thing?
14.
14 boxes, and we're talking about one box and one HA box. So this is the kind of scale we're talking about. This is why we're a very unique company in this space. And we're hoping today we can impress upon you that same very fact. So What do people use it for? I already kind of talked about this. It's high-speed replication, backup, large file transfers, and in some cases there's VM mobility stuff, some VMDK transfers as well, and I'll talk about that use case. But this is what we are all about. So we're very focused. We're a small company. We're going against very, very big, large companies. We need to really focus, find a use case that is replicable, pardon the pun, but just go and do it again and again and again, and we've done a very good job of that. So if you have 2 or more data centers, if you're talking about hundreds of thousands of miles, and you have an OC3 or higher, all the way to a 10 gig link, that's where we focus. We're not focused on E1s. We're not none of that brand stuff that other companies talk about. So that's what we are about. And let me give you 2 examples of problems we've solved. Actually, this slide is very timely because this morning, this customer, which is Time Warner, they've, in partnership with us, there was an article published in Information Management, which is this case study. So this was published today from the customer. So that's perfect timing for us to be talking to you on the same day that Information Management published this. So this is a cloud provider, which is using our product as essentially an infrastructure add-on to their existing system. So they had 2 1 gigabit links, so 2 gig WAN, MPLS, between 2 sites. San Jose, actually, is down the street, and Andover, Massachusetts. What they're pushing on that link is they're doing VMDK transfer, so they just take snapshots of the VM and just move it across the WAN for DR purposes. And they were doing DR, some DR for their databases. It was some Oracle DB data guard kind of thing that was going on. Before we got involved, they were getting about 400 or 500 megabit effective capacity on the 2 gig WAN. Now they get 6.5, 7 gig. So they went from 400 or 500 megabits to 6, 7 gig on a 2 gigabit WAN. So for a provider, that's awesome because now I don't need to buy more bandwidth. You know what? I can sign more customers. Nothing better than that. OpEx-wise, it's perfect. And they love us. They take calls for us from all customers possible. They're doing stuff with us in press. So it's a really cool marquee customer for us.
So VMDK transfer, they were doing this like file copy.
Yeah, basically.
Okay.
Yeah.
No
vMotion.
Good. You got my point.
Yes. No vMotion. Yeah, that's not. That's unicorn. Right? That's.
You said they were getting 6 to 7 gigabits per second on a 2 gig per second.
Yes, sir.
Link. So that's the effective transfer. But what was the link utilization at that time?
90 plus easily. Yeah. 90 plus easily. I mean, I remember because actually this deployment we had very few people here. So actually, the first deployment, Quentin and I went in and deployed the box and upgraded the boxes. They were pushing at very high speeds. Now over time, they've deployed it in other locations as well. They have a box in the UK somewhere. I don't know where in the UK, but they have deployed boxes in the UK as well. I don't know what the utilization is. Is it London? Okay, all right. So in London, I thought it was London. So the 2 things that are going on here is in traditionally WAN optimization, folks talk about 2 core feature sets. There's some sort of reduction of data, compression, deduplication. Compression has value, but deduplication is where you get a lot of value. And then there's TCP optimization. So when a 2 gigabit WAN is becoming more than 2 gigabit, it's basically the compound effect of those 2 things. It's TCP, it's some reduction. So we do a number of things on the reduction side, and Ashish will talk about that, as well as how we do QoS. Because when we talk about the system architecture, you find out that we actually use a Broadcom switch as our backend. So we can do a lot of QoS on our system as well. Comes for free on the Broadcom. So the combination is how we are able to get a multiplicative effect on the WAN. And at the end of the day, that's what customers care about, because I made an investment and I want to not upgrade anytime soon. How can I do that? Well, Infineta can help you at multi-gigabit speeds, and nobody else can. Wow, you guys are amazingly quiet. Is it the end of the day or no?
Maybe.
No, you're making sense. That's good.
Wow.
Yeah, that's a good thing. Yeah.
Can you tell my boss that?
No.
Isn't he watching?
I hope so. So yeah, we made sure he's not here. No top level guys, right? No, so one more example, and then I'll shut up, and the other guys can take over. Hey, Umair, you want to kick off your demo? Okay. So one more example. This is a very large bank. They had multiple OC192s actually between basically east to west coast. It's 85 plus milliseconds, a very long distance. Their problem was that they were doing EMC-based replication, so they were doing SRDFA off of symmetrics. The connections wouldn't stand up, so the replication traffic, it would just time out. Forget I don't have bandwidth, forget do I have reduction, it wouldn't stand up because TCP was becoming bottleneck. They put us in, we worked fine. So now, for them in particular, if we give them more than 10, kind of give them a multiplicator effect, that'd be nice, they don't really care. their application wasn't working without us because the distance was large enough. So this is the second type of use case for us. And this is an OC1. These are big links. This is a 10 gig link, 10 in, 10 out, 10 in, whatever out. It doesn't matter. It depends on the use case. In this case, like the slide says, we got 78% reduction, which is pretty cool. But again, the customer said, look, without you guys, it doesn't work. I can spend more money, buy more bandwidth, it still won't work. And that's the key thing. A lot of customers, initially when they think about these kinds of solutions, what they fail to understand is that adding more bandwidth sometimes, it's not gonna help you. Like the previous case, I have a 2 gig WAN, I'm getting 400 megabit effective. You add 2 more, what's gonna happen? Nothing. You're gonna have 400 because it's a TCP issue, it's a latency related issue, and that's what we do a really good job of solving at high speeds.
So what you're saying is you're deduping, or the compression capability you have actually reduces the in-flight latency of the TCP session.
Well, we do a lot of work on the TCP side in terms of congestion control. How we have this notion of active connection. I'm kind of stealing Ashish's thunder, but how we kind of manage the connections and how we using our network processor do a much better job of.
So there's 2 use cases. One is the straight out, I need more than this amount of bandwidth at multi-gigabit performance. So you'll provide more bandwidth, and you're also going to fix a latency problem.
Yes.
Or latency timeouts because you're going to reduce the amount. You can improve the latency by reducing the.
Just the congestion window.
They
manage
fix
the congestion
TCP.
window. Yes.
Because TCP over this latency won't work at this speed. So they fix TCP. They can't reduce latency. They can't make life
Or you
go
can't speed up
faster.
life.
No, you can't.
We have a quantum engine in the box.
Okay. You use tachyons.
Yes.
Yeah.
There's a bunch of quarks going this way.
Are these results due strictly to TCP optimization, or did you go up into SRDF?
So today we don't, but that's the plan. So and offline I can share a little bit more detail on that because that hasn't been announced yet. But we're doing a lot of work on that front as well.
This is just
right now,
figuring out
it's just we look at payload, TCP payload. How do we make it go faster? And that's how. And when we do more kind of prodding into the packet, understand the application, understand where a block starts and ends, we can do a much better job. But so far, it's pretty good. I mean, we're winning customers, right? Anything more is we have to figure out if there are diminishing returns or not. Sure. So far, looks pretty good.
So you're also doing deduplication.
Yes, sir. Okay. Yes, and so the crown jewel of our company is it's dedupe. And that's what Ram's going to talk about. That's his invention, and that's where he's going to get into the math around what was broken and everybody else how they do it, and what's broken with it, or in his opinion, what's wrong with it. Any other questions? By the way, Greg, thank you for summing it up. That's how we kind of do our elevator pitch. We say, look, either customers don't have enough bandwidth, or the data centers are too far from each other, or both.
Yeah.
Those are the 3 use cases for us. Very simply, that's how our inside sales guys think when they go and call somebody. So, is the demo kicked off? Umair, why don't you come over and... So Umair, who's also one of our product managers, by the way, he's our CCIE. So we have a token CCIE.
So you shift this demo to be at the beginning of the presentation.
So just smart. How's this going to work? Can you guys hear him okay?
Can you hear me?
Why don't you speak up and then I don't...
I'm good? Okay, thanks, Haseeb.
Switch over?
Right, we're good.
Yeah.
Not yet. I just want to talk about this a bit. So what we're going to do is do something similar to an EMC VMAX adaptive copy, and it's very similar to that. What we're using is an open source application called DRBD. It's a distributed replication block device. It does block level replication. You can use it for migrations as well. We could have done FTP, but this we're doing here is replication. This is kind of what our main.
It's more realistic.
Yeah, it's kind of what a typical use case is. This example is going to be emulating something similar to Chicago to San Jose, which is about 50 milliseconds on a 10 gig link. Think of it as an OC192. And what we're going to do is transfer 13 disk volumes. Each disk volume is going to be 125 gigabytes. We're going to set aside one such disk volume, and I actually kicked it off about 5 minutes ago while Haseeb was talking, and you'll see how that does at this speed. To emulate this WAN, by the way, we're using a Netropy Apposite 10G, so that's 10 gig, 50 millisecond latency, round trip time rather, and a few other points. This is 1500 byte MTU throughout the test bed.
No jumbo frames. We've heard your stuff before.
It's been a
so
topic
we've learned over
of
time.
debate about jumbo frames. There's been lots of going backwards and forwards about.
Right. And
they prepared themselves.
Yeah.
the other thing is the data on these disks is from real customers. We had a customer who was really nice to provide us some, so we put that on these disk volumes.
Okay.
So basically what's going to happen is 12 disks will run with us, one without, and the idea is that the 12 disks with us, they'll be done in whatever 25, 30 minutes. We're going to kick it off.
It's kicked off, yeah.
Both of them are kicked off?
Yeah, the unaccelerated.
And the accelerated?
Not yet. Let me just show the unaccelerated.
Are the accelerators starting off ignorant? Okay.
Yes, yeah,
I
definitely.
powered, yeah,
Just,
did that about a
They
couple
don't
of
should be
count. They
running.
don't have a disk.
Where's the browser?
Right at the bottom.
Something.
In memory.
Yeah, they have some file.
But is it populated?
All right.
Doesn't need.
It wasn't. It wasn't, to answer your question, though, because we rebooted.
Yeah, about 2.5 hours ago. Like I said, I'm first showing you unaccelerated traffic. This dashboard here shows you accelerated traffic. So what I'm going to do is go and see what is going past. This is actually being bypassed traffic. And you're seeing here about 11 meg in this bottom pane. 11 meg. Okay, now we've set aside a 10 gig WAN.
11 meg.
That's correct.
Actually, if you
10
just
gig link.
on a
Yes.
10, so it's a single TCP connection. Actually,
50 millisecond.
Yeah, so what are the window sizes they're using?
This is default, 128 kilobytes on Linux, default.
Okay, no wonder.
So actually, there are a bunch of TCP tools, like there are lots of TCP kind of sizing tools that you can find on the internet. Our competitors have a few of them on their website. If you plug these numbers in, you get the same answer.
Yeah.
So it's 11 meg. I mean, this is the thing, right? It's a 10 gig WAN, single connection, obviously, but it's only using 11 megabits, and you just wasted everything else. So that's really the problem, and people don't get it sometimes till you show them, right? And that's what we're trying to show them.
Okay, now can you just kickstart it?
Do you know? I'll do it.
Yeah.
So you could increase the window size in this connection, right? With tweaking.
So
Yeah, but to fill the pipe, it would have to be huge. The window size would be enormous.
Yeah,
And
I agree.
That's what we do.
So
but
there's one challenge with that. If you just increase the window size, if you have lost, so you're not going to have a pristine link. If you have lost and
go
congested
ahead.
links, then you have issues, because what happens is
Oh, no, this is
if
the
you have a
entire
lot of
link.
window
125
to
gig.
acknowledge,
Entire disk
if you
volume.
lose it,
Got it immediately.
Yeah, but my
select
concern
right?
here is
Haseeb,
what
can
if
you
you
just
don't.
kickstart it?
yeah. Sorry, why don't you answer the question? I'll
Yeah,
start the
Can you
demo.
repeat the question?
My question is here, and obviously increasing the window size to infinity or beyond.
No, there
it's
is
going
a
to increase.
maximum.
Yeah, no, it's going to increase the speed, but
That's
the
true.
problem, as we know it, is what happens if we drop the traffic. But my question is, what if we don't drop it? Why do we assume that we're going to drop something?
Because it'll always happen.
It's an IP network.
Such as life.
Yeah, I know.
It's not fiber channel.
So by the way, okay, if you have one link, if you have a dedicated WAN link, let's say it's a pristine, let's say it's an optical link that you personally put in.
Yeah.
If you have a single connection in the world, it'll be fine.
Okay.
But that is never going to happen.
That's never
That's the
gonna
challenge. So
happen.
typically the challenge that occurs is, I mean, we have one customer who said, look, I can spend as much money as I want on bandwidth. They had big fat VMAXs. What happened was they could make them aggressive. So aggressive means basically either you can change the congestion control algorithm on the sender, or you can make the windows larger. If you do that, what happens is they actually step on each other. And then at certain points, because at some point entropy kicks in, and then you start having massive buffer overflows.
Yeah.
And that's the problem. So you
if
can't
you
do
have
that.
one sender and one input, one output, you cannot have a congestion. If you have two
That-
inputs, one output, you will have a congestion at some
Yeah,
point
and
because of the
bursts will
asynchronous
kill you.
nature.
Exactly.
Yeah, exactly.
Yeah.
Exactly.
I agree with that, but
Okay.
my question is, why wouldn't the benefits of increasing the window size outweigh the drawbacks, which would be the increased, which would be the decrease in the transmission rate? I mean, if I just increase the window size, what am I going to lose, other than some of the
I think
retransmission?
I'll let Ivan answer that question.
In an ideal world,
I'm not
running
talking about the
fiber
ideal
channel,
world.
single
Yeah, yeah.
sender, single receiver,
Yeah.
you can get what you wish.
No,
this is-
that's not at all what I was asking.
No, the
I was
problem is
asking-
that the moment you lose a packet, the retransmission will bring down the throughput.
Yeah, okay, fair enough. I'm saying, at which point would the number of retransmissions become a problem? A single retransmission isn't a big deal.
So if you're not using selective acknowledgements, depends on where you drop the packet. So the way TCP works is if you
Let's
drop a
assume that I
packet,
am using selective.
so if you're using selective acknowledgements, so the way, okay, let's actually maybe discuss
Marcus,
what a
still
loss
the
is.
transmission stops because you have to.
You have to wait for latency. You have to wait for an RTT to
Because
send the packet back again.
It drops down by half, but again, my question is, at which moment am I going to become having a serious problem? Obviously, 10 megs on 10 gig link is
So who
serious.
is going to do a PhD on that?
Okay. So
Well,
let's
that's
see
been
what
discussed.
happens.
Actually, this
we
might be a good
haven't gotten
segue
to
for our
Too far
PhD.
from the demo yet.
If I remember
So
the
the demo-
calculation
I know
correctly,
Let's see the
the
demo.
packet
But
loss,
I mean,
as the packet loss goes up, the throughput exponentially goes down.
So it's inversely proportional to the square of that, actually.
Right.
fair
So
enough.
Yeah.
Yeah, at this scale though, that's the real problem is on the hosts. We're talking about massive buffers and management of those. You know, that's, I mean,
Okay, that argument I can buy.
the windows,
Yeah,
the
I agree.
windows
Yeah,
to support this would be
That
so
I can buy.
huge,
That I
buffer
can buy.
management would.
Thank you, Eric. Yeah.
That I can buy. That I can buy.
Yeah, there's so when the funny thing about TCP is, look, everybody, I've met a lot of TCP experts, and then things go wrong and nobody has an answer. It's such a crazy protocol. People have been working on it for 30 years, nobody gets it.
Yeah. And you've also got to remember your WAN provider is going to have a lot of buffers. Because the WAN provider says we drop less than 1 in some vanishingly small percentage of TCP packets. And the way and that's a quality metric, because a lot of people just say, does your network drop packets? And they say, no, we guarantee you we only drop, 0.001% of packets. The way they do that, because TCP inherently drops packets. So it must drop a lot of packets, because that's what TCP does. So what they do is they put in massive buffers, 2 megs, 4 megs, 8 megs. It's called buffer bloat. And then what happens is they retransmit them to the other side, but by the time they've got to the other side and not been dropped, the source has actually retransmitted them. And so
Yeah.
you actually get this recursively reductive TCP handling.
Okay,
by the way, you're using
this demo,
64K.
so we're seeing the demo here, clearly you're filling up to 6.75 gig with the acceleration turned on.
Yes.
And you have
64K,
80% data reduction.
Yeah.
Looks like it. Is that right? Yeah, 70 average and
Yeah,
whatever
is
it
it
is. It's hitting 80%. That's correct.
Okay, where's the algorithms, guys?
Look at that. This is, yeah, let's do that. So what I'm going to do right now is just note down these numbers. What we saw, I think, was like, I'll do a with and without. So without, we were like 11 megs, and with, and then I'll note the time real quick, what time we started, and we'll come back.
So these are separate links, though. You're demoing 2 separate links.
Two different things going
Okay.
kind of like this.
Okay, cool. So what's the utilization of that link?
Oops.
Total? Sorry, I missed it somewhere in all the chat.
Let's come, we're going to come back.
Why don't you write
with-
it down?
Yeah.
So it's 6.75 gig on one and 11 megabits on the other or something.
Okay,
like
yeah, I got the first one. Thanks.
So, I just wanted to address one point that Greg made about latency. So when queues are deep, the challenge with TCP is the way timers work is they assume no queue delay between the sender and the receiver. So if there's a queue delay, what can happen is that the TCP thinks that I lost a packet, and then you start retransmitting. So there's a bunch of things that go on, and unfortunately, as a sender, as if I'm just a server guy, right? The best I can do is on Linux, you can change the window size. Actually, you can make it. I think the max is like 12.5 megabytes or something. It's a huge window, right? You can do that. You can turn on SAC. You can actually make it aggressive. So instead of using Reno TCP, which is what the typical is, you can use Big. You can use HTTP. They have a flurry of things that you can do on Linux. But when you again, like we discussed before, if you use one connection, beautiful. And this is, by the way, this if this is of interest to you, we can actually demo this for you at a later time. Run 10 connections, and I'll show you packet drops.
Yeah,
Even though there should be.
no.
Yeah.
I perfectly understand that. It's something that people usually don't get.
Yeah.
I actually do.
So,